Hello, this is Mr. Stone, and in this video we are going to learn about chemical equations. Reviewing this video, you should be able to distinguish among elements, compounds, and molecules, determine how a chemical reaction satisfies the law of conservation of mass, write a balanced equation, and identify some common chemical reactions. This is important for you to know because chemical equations are the language of chemistry. Here you can observe a change taking place, but how would you know if this is a chemical change? Quick review, remember a color change, a change in odor, bubbling and fizzing, light production, smoke, or the presence of heat. These would all be indications that we've had a chemical change. Essentially, a chemical reaction is the same thing as a chemical change, so that's what we're going to use now, is chemical reaction. Whether it's some kind of explosion taking place, an old metal car rusting, some ham in the refrigerator turning green, a thermite reaction taking place, or even mixing vinegar and baking soda together, all these chemical changes we're going to refer to as chemical reactions. So in chemistry we have a special way to represent these chemical reactions. We use what is called a chemical equation. Before we get into chemical equations, we need to make sure we understand an important law known as the conservation of mass. So what this scientific law tells us is matter cannot be created or destroyed. So what's really taking place is the atoms in a chemical reaction are just rearranging. A new product is being formed. But we have to remember the total mass before a chemical reaction is going to be the same as the total mass after the reaction. So another way to say this would be the starting mass equals the ending mass. In order to apply this law correctly to a chemical reaction, we need to make sure we understand a few things. First is an element. So remember, an element is one kind of atom. So here's an example, lithium. Lithium is element number 3 on the periodic table, meaning it only has 3 protons in its nucleus. Every atom of lithium is going to have 3 protons. We need to be able to distinguish elements from compounds. Compounds are made of elements, but they're a thing that is composed of 2 or more separate elements in a mixture. You can see this compound is made of 2 atoms of hydrogen, 1 atom of oxygen. You know this compound as water. This next idea is a molecule, which is a neutral particle in which atoms share electrons. So molecules can be elements such as the hydrogen gas here, H2. We could also have molecules for compounds. Water is a compound, and here is an example of one water molecule. Understanding these parts will help us to be able to read this idea of a chemical equation. In this chemical equation, you'll notice there are 2 sides separated by an arrow. The left side of the equation, these are known as the reactants. So this is the reactant side. On the other side, the right side of the equation, are the products. So the right side is the product side. So you'll notice in this chemical equation there's a plus sign. All those plus signs tells us they react with. We also have this arrow that we pointed out. It means produces. So this is telling us what the new substance is going to become. So the way we would read this chemical equation, we would say acetic acid reacts with sodium bicarbonate and produces sodium acetate, water, and carbon dioxide. This is the chemical equation that shows us the chemical reaction of mixing vinegar and baking soda together, and we get that bubbling and fizzing. According to that law of conservation of mass, however much vinegar and baking soda we end up with, we have to have the same mass after the reaction has taken place. As a result of this scientific law, we have to balance all chemical equations. Balance equations, you're going to have to make sure you can count atoms correctly. So here in a molecule of the compound methane, which is CH4, we can see that there is 1 carbon atom and 4 hydrogen atoms. In the second example of the compound ammonia, NH3, the N tells us we have 1 atom of nitrogen, and the H3 tells us we have 3 atoms of hydrogen. In practice, balancing the equation using a very familiar compound, water. So here's an example of how water can be decomposed into its parts, the hydrogen gas and the oxygen gas, because you know that water's molecule is H2O. So let's practice with that one. This is the chemical equation to represent that reaction. We start with water, H2O, and it's decomposed into hydrogen gas, H2, and oxygen gas, O2. We're going to need to count the number of each kind of element, each kind of atom on both sides of the equation. So let's start with the left side, the reactant side. Our H2O, that H2 tells us we have 2 hydrogen atoms. The O tells us we have 1 oxygen atom. As we count atoms on the product side, we have H2 telling us we have 2 hydrogen atoms, and O2, 2 oxygen atoms. We can see that this equation is not balanced. We have more oxygen atoms on the product side than we do on the reactant side, so we have to balance those out. So we can't change the numbers below because we can't have H2O2, that wouldn't be water anymore. So we add a number out in front telling us we have more molecules of water. That number out in front, that is called a coefficient. So now we're going to have 2 water molecules, and then on our product side we're going to have 2 hydrogen molecules and still with 1 oxygen molecule. So now counting up, that 2 in front of the water molecule tells us we have twice as many hydrogens and twice as many oxygens as we had before. So we have 4 hydrogen atoms now and 2 oxygen atoms. On our product side, the 2 coefficient is just in front of the hydrogen gas, so that only is applied to the hydrogen, not the oxygens. So we have 4 hydrogen atoms and still 2 oxygen atoms. So now as we compare the atoms on both sides of our equation, we can see we have the same number. We've satisfied that law of conservation of mass. The ending mass is the same as the starting mass. Alright, so let's check. Did you learn how to distinguish among elements, compounds, and molecules? Did you learn how to determine how a chemical reaction satisfies the law of conservation of mass? Did you learn how to write a balanced chemical equation? And now can you identify some common chemical reactions? Well, this is Mr. Stone. I hope this video helped.